Now, as you can see, we have basically a command window, and there's also a blinking cursor. So this means that we are basically dealing with a interpreted language rather than a compiled language. So let me also show you Visual Studio here. For example, if we use C or C++, we have um, this includes stuff here, stdio.h. We will have an main function. I'm just typing it, for example, it will return 0, something like this. And we are basically coding in here. Once we are done with the code, we have to compile this because this is a written text file, basically, run.c, for example. But in order to be able to see what it actually does, we have to basically compile this. And during the compilation, it will generate an assembly file, for example, or even a machine code. And this machine code will consist of ones and zeros, something like this, some random 1 zeros. It will look like this. And since we're using Windows, it will be an exe extension, something like this, and we will run it. Now, we have the code, we have to compile it into machine code, and then we can execute it. But that's not the case if you are using, for example, Python or Matlab, because you already have something that will communicate with you that already waits for commands here. So we will write codes that will look like this, but it is not going to be compiled into machine code. It will be directly executed because we have a virtual layer that gets rid of this whole compiling and then rerunning stuff. And this also brings up the topic of utilization of the programming languages. If you are using C, C++, something low level, your aim is to write code that runs fast, gives out performance, but it's not really flexible. You have strict rules to follow, but it has its pros and cons. It's more suited for the application deployment, basically. But if you're dealing with MATLAB Python, you have a flexible environment where you can just go ahead and try stuff, rerun the code, try again, until you find your actual, let's say, algorithm. So therefore, this environment is a more of a laboratory where you experiment with stuff, and C, C++ low level is for production. I don't want to use MATLAB if I am a car manufacturer and I have an algorithm that's already well thought and well designed. I will just deploy it, then I will use a low-level programming language. But here we have a high-level programming language because we will use this programming language in order to understand stuff. It's a more theoretical and philosophical approach here. For example, variables. That is going to be one of the important things that we will use. We can define variables in C. Let me just maybe create something like main.c, something like this, in order to have the right coloring here. So if I am going to define an integer, for example, I can just do this, int, which is the type of the variable, and then this will be the name of the variable. And here in MATLAB, I don't really use the type here. What I'm going to use is just I'm going to give it a name. And that's basically it. Now, if I type in A, you will see that we will have an error message, and it says that it is an unrecognized function or variable A. So here, of course, I'm not going to compile it, but here this wouldn't be an issue at all. Now, what is the reason behind that? We have also a character, let's say B, a bool, C. We have these variables here. Bool is for some reason was Boolean. Yeah. Bool should be correct, but yeah. In Matlab, there's no differentiation based on a keyword like int, char, bool, etc. It is rather based on its value. Now you can see that if I, for example, say int a equals 29, character should be, let's say, C, and the bool should be, let's say, true. Now you can see that the values are somewhat aligned with the types. Integer can hold up numbers, and characters like charb should have characters in it. And if it's a Boolean or logic value, it should be 1 or 0 or true or false. Now, it is kind of possible to look at the values and then determine its type so that we can maybe get rid of this int char bool, this whole type definition. So in order to do that, we can just directly assign a to something, let's say 29. And there we go. Now we have defined the integer a29. Now, once I have defined something like this, or a equals 29, once I've typed it in, I can see that in the workspace, we have the name of the variable and the value of the variable. Now, this is the reason why I have why I recommend you to use the Matlab GUI if you're not really familiar with programming or Matlab at all, because it has this little features that help you out throughout the process. Now you can see that the variables will appear here in the workspace, and they will have some values and names, and then you're good to go. You can also see what I have typed in recently. So what about B? Let's say B should be equal to character C. Now I have typed in basically the syntax aligns with C, so that's the reason why I'm using C for examples. But we can see that assigning stuff works because it is B. Now we can see that the value is using single quotes and C. Now I can also say C equals true, and it gives me something else. Now, of course, I see that there's something that's not the same. It says that it is 1, it is equal to 1, but it is logical. So Matlab uses this logical instead of Boolean. And if you click it, it should also open up a little help here. Logical, it is a numeric to logical conversion, and it can hold true, false, 1, zeros, and that's basically it. So it is fairly easy to define variables in Matlab, as you can see. It is also somewhat similar in C, but in C we have to give it a type, assign a type to it. Now, if we have integers, characters, bools, and if we can go ahead and define them and determine its type based on its value, why do we still need to use C in certain areas and then define this bool and char and int? Why is C much harder? Because this is much simpler. I can just type what I want and I can just execute it even on the fly. So why do I still need to learn C? Why is there Matlab, and why doesn't everyone use Matlab? Now, let me give you an example. If I want to hold, for example, values in an array, let's say A1, A1 is equal to 29, and then A2 is equal to 30. And then for some reason, I decide to say A3 should be equal to true, and then A4 is equal to 40. So I have to find some variables, and if I do the same here, let's say A1 is 29, so 29, 30, and then A3 is equal to, let's have that, A3 equals to true, and then integer A4 is equal to, what was it again, 40, something like this. Now, since here we have, since in Matlab we have something called logical, it is possible to just align the memory and just define A3 equals 1. But if I'm going to implement it myself, what I can do is I can just assume that A3 is true, and I can just go ahead and use the value 1. Since it is basically the same, if you have logical 1 or Boolean 1, it's still something like this in machine language. There should be 32 digits here, but you get the idea. There will be 31 zeros and just a 1 in the memory, in RAM, on the computer. And if I define something like int, it will be basically the same. The only difference here is the meaning. I think that this is true, and this is a decimal value 1, or an integer, and that's it. But in the machine language, if you go ahead and debug it, you will see that it is basically the same. This value will appear on both of them. Now, doing this here, int, is one way of doing stuff. If I do this and treat this as a logical value, it will be okay. So what I can do is I can just drop the whole Boolean and logical stuff, and I can just opt for the integer. Because it is possible to do something like this. Let's say A equals to C. Now I can treat A as a value. So it is interesting and also important to note that those characters are not really characters. They are numbers, they are values. If I can add 1 to it and get the result of 100, it seems like A should be equal to 99. So this means that A equals C is also the same as A equals 99. Of course, they don't give the same result, but there should be something like this. You can see that I can do type conversion in Matlab. And if I type in char and provide the number 99, it will give me the value C. So in 32, C should give me 99. So you can see that basically those are the same. So 99 means C, or C means 99. So basically what I'm trying to tell you is the following. If I have char, let's say C, and it is equal to C, this is nothing else but int A5 equals 99. Of course, there's a difference, but not that big of a difference. So we talk about this 1 zeros and stuff in the variables. You can just picture something like this. There are zeros everywhere, and you can maybe space them byte by byte. So let's type in 1, 2, 3, 4, 5, 6, 7, 8. So this is 1 byte of memory. You have this memory here of bytes. And if you define a variable, the first one becomes your variable. Now, do you know how many bytes an integer is takes space on the memory? So how many bytes is an integer on a computer, on a usual computer? Now, since this is in 32-bit mode, it will be 4 bytes. So if I define an integer, this is the space that I need to define A1 equals 29. So what you can do is you can just convert 29 into its bits, something like this, for example, this will be 29. So this is also called A. So it's all about the memory, basically. If I do, this should be A1. So if I repeat it with this, let's say, I don't know what it looks like, but it should look like this. Just an example. A3 is equal to 1, so this is the easiest one. Then we have A440, some random 1 zeros. And then we will have the character C. Now C, again, is 99. So what it should do is basically, let's call it C here. It should represent the number 99. I don't know what the representation now is, but something like this. And then we will have A5. It should be just 99 again, the same thing. But there's a but here. It's not really the same because the character does not take this much memory. The character here is an unsigned integer, and it takes up only 8 bytes, 8 bits, just 1 byte. So it's a uint8, basically, an unsigned integer with just 8 bits. So this is basically saving 3 bytes here. So if this is a memory, I will take up this much space for 4 integers, but just 1 byte of space for C, and then this one here. So technically, which is not possible, but which should be possible, is that just 1 byte should be just 1 bit. I mean, the Boolean value should be just a single bit flag here. Most of the times, if you are familiar with embedded coding or stuff, the way that we use this is to assign flags to each position. So for example, if I have multiple Booleans, I will just use one of these bits here for that. So in order to save some memory space, because on embedded systems, memory is expensive, I want to save memory. So I have to deal with all these integers, characters, strings, whatever data types I have to deal with them because I have not that much space. I want to have cheap designs, therefore memory should be used effectively. So this brings me up to the point where I can say the following. In Matlab, we don't really care about this stuff. What we essentially do is it somehow visible here? Nope. But in Matlab, instead of using integers, instead of using floats, what we do is we just use doubles. And you know that double stands for double precision. I misspelled that. Double precision, so it's twice as much as float. So it's this huge thing here. So something like this, by the way, I'm not quite certain with this, but we just use this space for everything. Here, 29 can be optimized, for example, to an uint8 or int8 at its best, because up to 256 we can just use, or 128 and minus 127. In this range, I can use an integer with 8 bits, just 1 byte. I can represent this number with just 1 byte, and I can save space. But in Matlab, I'm using this much space for it, maybe even 8 bytes or 16 bytes of memory. We don't really care about that because we don't want to optimize our algorithm or code for anything special. We're just looking at the code, or we're just coding for theoretical purposes or design purposes. So we have all the memory we want. Therefore, it is easier to learn and master Matlab because you don't really have to deal with this memory saving stuff or with different data types, at least not for simple tasks. If you're interested in, again, complicated stuff, you might want to still check out what uint8 is, for example. You can define uint8. So, for example, if I type in something like this, it can only represent 255 because it's 8 bits, 1 byte of memory. And if you just give a big number, it will be cut off and equal to 255. And you also should not be able to assign -1 because you can see it is just 0. It cuts off for negative values and equates it to 0. So if you want to still save space and then just define data types, as it is the case in C, you can do that, but you have to enforce it. Otherwise, it will be a double value. So 1 divided by 2 gives you 0.5, and it will be always a double. In C, there's a difference here. If you divide 1 by 2, you don't get, basically, as far as I remember, you don't get 0.5, you get 0 because you're working with integers. And the reason behind that is that we have a central processing unit, CPU, and the arithmetic and logic part of a CPU is important for us because we're dealing with that. If we have mathematical expressions or logical expressions, the arithmetic logic unit is our piece, because nowadays in phones and mobile phones, we see that there are neural engines, graphical units and stuff. There are also arithmetic logic units in that. So if we add two numbers or divide two numbers, what happens is that we will have a basically we provided a value here. Let's say this is A1, another value A2, and then the operation, for example, sum or subtraction or division. So the CPU does this and gives us the result. If you provide two integers, it will return integer, therefore providing just one of them as a double or float. If you remember, should solve it because it assumes the biggest data type here. So it recasts it back to the same size here, something like this, and returns the result in the same data type. So as you can see, as more as I speak about the C language, it turns out that I need to know on what platform CPU I'm working on, because it depends on that. If this is a 32-bit CPU, it can only handle 32 bits. If it's a 64 one, and the memory is also 64-bit, then you can work with bigger data types. But in Matlab, I don't really care. There's a unified language. I just give it data, it processes it, and it just returns it. Nothing complicated about that. So enough with C and C++ today. Hope that you get the basic idea here. We have data types, of course, but here in Matlab, we have simpler data types because we care less about memory. We care more about flexibility. So if I define something, it is a data type of double. And yeah, and I can do just random stuff with it. So if I want to have true or false, I can have that. Those are Boolean values. But here in Matlab, we use logical. This is the keyword that is important. And you can use this as a function call, logical, and provide it some value, and it will convert it into true or false based on the value. And as far as I remember, if it is a negative value, we should still get 1. Only 0 gives you a 0 in logical, but other than that, you can just use true or false because that's most likely the case. If we are dealing with characters, interestingly, we can use just one character, or in Matlab, it is possible to provide multiple characters, because most of the time in C, you can just use just one character if you're using the single quotes. Here you can see that's not really the case. Now, what would happen, it should be in 32, if I provided this single quote, because I've talked about memory and I said that this takes up just 1 byte of space, but it is a number. It is an unsigned integer of 1 byte. So what will happen if I convert it into this, or even int 8? So you can see that basically this is not a character. It is basically a vector or an array. So there are multiple characters, and MATLAB recognizes this and says that, okay, single quote started, but we have multiple characters, so let's allocate that memory and just define this variable here. So you can use this. So let's define, let's say, word equals this. And you can also access it using just parentheses. The first letter of this word is A. Then the second word is basically also A. Let's have this third word. You can see it is S. So it's basically an array. And in C++, we would just define the array, give it a size, 23, define it, and then maybe fill it out. And the biggest difference here would be to just use 0 as an index, but that's not the case in MATLAB because we start counting at 1, so MATLAB starts at 1. So you don't do something like word 0 because the indices in MATLAB should start with integers 1. So there are some differences, but you can get used to it. And it's also interesting to see that in MATLAB, you don't really have to stick with the size, but as you might already assume, it just counts the space that is needed here, calculates it, and allocates it. So you can do allocate 7 characters array, but you don't really have to because MATLAB does it behind the scenes. So since I'm already talking about arrays, in MATLAB, if you want to define an array, you cannot do something like this. 1, and then the next one should be 34, and then 54. It's not possible. We need to use some delimiters or some characters for this. And since in C, we have these square brackets, you can just come here and put these space brackets. But now, since we are defining stuff based on the value, the square brackets are basically containing the values. And this will form an array here. I deleted accidentally the stuff here, so let's add it back. So now you can see that arrays are defined using square brackets. Then we have some values. We separate them by space, or if you want to be fancy, you can just go ahead and use commas. It has the same effect. And we have defined our first array. You didn't provide any size, you didn't provide any type, but you defined an array. So it is quite powerful if you think about it. And interesting fact, let's say ABC here. What I can do is I can also define this by separating the values. I want to have the character A, I want to have the character B, I want to have the character C, so I can just form an array, and it gives me the exact same result here. So this is basically an abbreviation here. It's a shortcut for squared, and then each character separated by commas, and then square bracket again. So it's basically painful to use this notation, and you don't really have to. You can just use the single quote method here. But if you do this and add 1 to it, you will see that 98, 99, and 100 will be the results. So this single quote thing here is not really a character or a string. It's not text data. It seems like it, but it's not. It is just numerical values of 1 byte each. In C++, we have this string, std string, if you're familiar with it. So this exists in MATLAB, and we have these double quotes for that. So I can also define ASD or ABC or whatever the word is. But if I use double quotes, it's also possible. And the usage is basically the same. Just put 1 at the beginning and 1 at the end. It's the same. So why do we have both of them? Do you have any idea? Has anyone any idea about this? Why do we have single quotes and double quotes if they are the same? Why is it confusing? Because should I use single quote, or when should I use single quotes? When should I use double quotes? Any ideas? So no one knows really here. Okay, let's make an experiment. So yeah,
Hocam kesme işaretiyle ayırmamız gereken yerler olduğu zaman mı double quote kullanıyoruz acaba?
Yani olabilir ama hatırlarsan şu ters işareti vardı. Şöyle göstereyim. Ben de şimdi emin değilim
Evet,
çalışıyor mu?
ondan kaçınmak için kullanıyorduk.
Bunu kullanıyorduk normalde. Dolayısıyla o olmayabilir. Ya da bu tek başına kullanılıyor mu? Yok, kullanılmıyor. Ama daha önemli bir fark var. Dediğin de doğru bu arada. Ona da geleceğiz. Now, what about if I'm using just a quote here? It's not really possible to start and end with the quote here, the single quote, if I want to use it as an apostrophe. That's also one usage. There will be a difference here because I can do it here now, as far as I remember. So that solves it, but it also implies the actual answer here. And let me do an experiment. If I have ASD, so ASD plus 1 gives me this result. What happens if I use double quotes here and add 1 to it? Now, this actually is a text data type. So if you add something to it, if you do stuff with it, it will try to convert everything into text and treat it like that. Whereas this one was basically just a representation, and the values are actual numerical values. So this is not a numerical data. This is basically text data. So adding one or adding anything to it tries to append it to it. So it will extend the string and add 1 to it. So that's basically a difference. So it treats this, for example, it just creates another word consisting of both of them, but otherwise it would just add them together numerically. So in Java or in C# or in other high-end languages, if you want to manipulate strings, or in C++ even, you just use the string data type. That is a special class or object. It has string capabilities. You can search for a character, you can just split these, you can just look for a delimiter, etc., etc. So this double quote here in Matlab represents that complex string or text data type. Whereas this one here is just the simplest representation of text data. If you don't want to str replace strlen or stuff like that, if you don't want to use any text related function, you can just stick with single quotes if it's just basic text. But if you want to do stuff with it, double quotes will have the upper edge because it has string capabilities. Yeah, there's a function called length, and we can use ASD for that or double quotes for it. It doesn't really matter. But here you can see there's a difference because now the length of the data type here is, this is a unique object. So there's just one object. So therefore the size or length is 1. Whereas here there are 3 different numerical values. So therefore the length is 3. So there are differences. It is more about the utilization of the data type that you want to choose. So if you're just dealing with basic text, stick with single quote. If you're doing complicated stuff with strings, just go ahead and use this. So let me open up my notes now, and let's see what we have covered so far. So I will actually upload this PDF so you will access it. Yeah, I have talked about different numerical types. If you use a dot, you can just define floating numbers. And this is the way of defining an array. And you can just have different variables and then create an array out of it. we have some functions called zeros and ones. By the way, I'm typing CLC, that stands for clear command window. So CLC is kind of CLS in CMD, if you know CMD. Let me show you. So CLS clears the screen here. It's an old thing here. And the MATLAB version is CLC, clear console. I use it a lot. If you use clear, pay attention to the workspace here. If you use clear, it gets rid of all the previous defined variables. Because we have a MATLAB session, once you open up MATLAB, you will have a MATLAB session. And it goes on, its duration is just infinite. If you close MATLAB down, it will close down, clear the workspace. But other than that, you might want to go ahead and delete that previous data, or you might also not want to do it. So it's basically, it depends on your usage. If you want to get rid of a specific one, let me just show you. Let's say we have A and B. I want to clear A. You can just go ahead and get rid of A, or you can just type nothing, just clear, wipes out the whole memory. So CLC. There's also a close all, but this is not relevant at the moment. But if you have some figures, if you have opened up a graphical user interface, if you call close all, the figure vanishes. So those are things that I use often. Now, for example, we have a command called zeros, or length in this case, but let's say you don't really remember how to use it or what it really does. You want to seek help here. What you can do is you can just type in help space the keyword, and it will pop up an immediate help, which is just very short and is aimed to remind you of stuff. So if you don't remember it and you want to be reminded, use help. If you want to learn it, if you don't really know anything about it, you can call doc for documentation and enter it, and it will pop up a new window, which is a much detailed help, and it teaches you from scratch. And if you Google it, let's try that out. So let's go ahead to Google. If I want to Google, let's say MATLAB, and what it is was length. If you type in like that, the MathWorks site that opens up is basically the same. It's the same website. So side by side, you can see that all the same examples and even less data, I guess, interestingly. Oh, other usages. There are multiple of them. Let's search for zeros. Maybe that has just one usage here. Help doc zeros. You can see that it will open up this site here. And if I Google MATLAB zeros, it should be this one here. So it's basically the same here, the same website, as you can see, just the same thing. But the nice thing about this is, since you all are students, sometimes you don't have any internet connection. This doc here doesn't really need internet connection because it's offline data. So if you have no connection but still want to learn what stuff is, or if you don't remember it, you can just use doc and then the command that you're looking for. It doesn't require internet, as far as I know. So now, what is this zeros and ones? Well, basically, instead of doing something like this, 1, 1, 1, 1, instead of defining an array that consists of just ones, you can go ahead and create ones. Use this function here, and let's say 1 by 6. So 1 row and 6 columns. So therefore, you create this. So it's a shorthand. It also works for zeros. But still, since we are in MATLAB, and the abbreviation is Matrix Laboratory, instead of having vectors and arrays, what you actually have is matrices. So if you define a vector, it's actually a 1 by, let's say, n vector. So it's still a matrix, a row vector, a column vector. It's a data type based on matrices because MATLAB is intended to use for matrices. So therefore, rows and columns are the things that we use the most. So let us do a little exercise, and let me show you how to define a row vector. So we've seen this already. It is basically using commas, square brackets, and just give the elements. It will create a row vector that has just one row and 3 columns. What about if you remember the mathematical transpose here? What about the transpose? Since if this is a matrix, I should be able to take the transpose of it. But here in MATLAB, we use this apostrophe here, or the single quote here, that I use for characters. It's the same. If I just use one single quote and use the variable, it takes the transpose. So as you can see, it is not really an array in the sense of C++ or C or other low-level languages. It is a matrix. So there's a difference. And you can see actually there shouldn't be a transpose of it if it would be an array, but there is. So this is a matrix basically. So how can I define a column vector? Of course, I can take the transpose, it does the job, but I want to define a column vector for some reason. Now, the understanding in MATLAB is that if you use comma, you will separate them side by side. If you use something like this, a semicolon, it is just underneath, stacking underneath. So you have this movement here. So if you want to define column vectors, you can just go ahead and use semicolons. So what about, let's have x equals 1, 2, 3. Let's say I want to create another vector, but I want to stack them so that it will create a matrix. So the first row is 1, 2, 3. Let's have the second row 1, 2, 3. How can I do that? Well, since the semicolon is just entering in the sense of a keyboard, so you hit enter basically with the semicolon, you can do the following. You can say that the first row will be x and then go 1 down. The next row will also be x. And it will just create you this matrix here. So is it also possible to define it in a different way? Of course. How can I use a different approach for the same results? Any ideas? I want to do the same thing, but differently. What I did was I typed in the first row and then used a semicolon and then the next row. Now I want to take a different approach. How can I do this? Any ideas? I want to use only commas here instead of semicolon.
Once function.
It's possible, but we have 2 and 3 here, so it will not be possible to do something like that. So let's assume that I have, for example, C1 equals this here. That would be 1, 1, C1. So that's the first column. Let's have the second column, 2, 2, and then the third one, 3, 3. So how can I stack them together so that I get the same result here? Basically, I have to do the following. Use a square bracket, stack these side by side, C1, C2, and C3. So it gives me the same result here. The only difference being that I stack them side by side instead of on top of each other. So here I defined a row and stacked them on top of each other. Here I defined the columns and stacked them side by side. So let me rewrite this in a more compact form. So 1, 2, 3, and then again 1, 2, 3. So that's one way of doing stuff. Or 1, 1, and the next element would be 2, 2, and then the next element would be 3, 3. It's again the same. So there are different ways of doing the same thing, but you can see what a semicolon means, what a comma means. This is important because most of the time you will end up in dimension errors, and the reason would be the lack of understanding of the operator comma and the operator semicolon. And as an exercise, let's try the following. In Matlab, we can get rid of these extra brackets here, square brackets, and do something like this. And this is the most standard form of defining matrices, because 1, 2, 3, it's the first row, go one row down, and define the next row, 1, 2, 3. So this is basically the matrix notation that you can use in Matlab, and that most of us use in Matlab. And you can see that this is basically based on the fact that 1, the next element to it is 2, the next element to it is 3, go 1 down, and then the first element is 1, the next one is 2, next one is 3. So this kind of algorithm is also here. You can see that it works for this one. So what about this one here? Since I have already this here, let me get rid of the square brackets, the extra ones here. So what will happen if I hit enter? Will it work or will it fail? What do you think? Şimdi ne yaptım? Aslında köşeli parantezleri çıkarabiliriz dedim. Virgül koyduğum zaman yan yana koyuyorum elemanları. Noktalı virgül koyduğum zaman alt alta koyuyorum elemanları. Burada da yaptığımız şey aynıydı. Geldim buraya, dedim ki fazla olan köşeli parantezleri çıkaralım. Birin yanına 2 gelecek. Onun sağına işte 3 gelecek. Bir satır aşağı in. İlk eleman 1. Onun yanına 2 gelecek. Onun yanına 3 gelecek. Bu şekilde yaptığımızda enterladık ve çalıştı. Peki aynı mantıkla bu yazdığım çalışır mı? Çalışmaz mı? Soru bu. Ne diyorsunuz? So if I hit enter, I'll get an error message. And the reason is the following. So I told Matlab to place just one. So let me just copy this here and go to here maybe. And let me show it here. By placing 1 and then semicolon, what I do is I do the following. So let me get this. So if I see a semicolon, I'll hit enter. So 1, the next element is 2, and I hit enter. 2, 3, I hit enter. Now the problem here is that we have inconsistent sizes, because 2 elements are here, but there's not enough another elements here the same. So if I want to work with this, what I have to do, for example, is to place some arbitrary elements next to it. So let's try this one out. You can see it works now. And the issue being that the zeros should not really exist is that it lost its meaning. This is basically not the matrix that I wanted to define, because this was the command and this was the outcome. This is not the same. And we have a size mismatch here. Dimension array being concatenated, so put together, are not consistent. So it means that each row should have the same size if you're stacking rows on top of each other. But here you provided just one element and then hit enter, and then 2 elements hit enter, 2 elements hit enter, and then 1 element. So it's not possible to combine them into an array. These types of errors will come up time to time, and you have to just check for your dimensions and your elements. Maybe there's a size mismatch. So that was the thing that I wanted to point out to you. So if you use commas, you concatenate or stack columns. If you use semicolons, you are concatenating or combining rows. So be aware of that. Once you get the idea of comma and semicolon, it will be much easier to debug these types of errors and problems. So let's get rid of this. Of course, in C, this loses meaning because you have just one place of memory of ones and zeros. There's no vertical movement, no horizontal movement, no column or rows by definition. So these problems do not really exist in C. So now, how can I access the elements of an array? Let's also see how we can do that. So if I type in CSC, I get rid of the whole thing here. So let's say I want to access the first row, second column. So what I do is first row, second column, and that's basically it. It's not really that big of a deal. But the problem is, once I am exceeding the size, it will say that array out of bounds, which makes sense because there's no fourth column. But what will happen if I, for example, just treat this as an array and type in 1? So what is the first element of A, even though A is a matrix? What do you think? Will it crash? Will it run? If it runs, what will be the value? Should it run? Let's hit enter. Now, interestingly, I can access it via rows and columns. That's good. But I can also treat it as a one-dimensional thing, even though it's a matrix. Now, the most interesting thing will happen if I look for the second element here. So what do you think is the second element of this matrix? 1, 2, 3, and then 1, 2, 3. So what should be the outcome? If the first one is 1, what is the second one? Any ideas?
2.
2. Any other ideas? So let's see. Interesting. What about A3? So let me just show you A again. So this was A, this is A1, this is A2, and this is A3. Can you see what's happening? Maybe A4 can help you out. Matlab, behind the scenes, does not stack rows. It stacks columns. So the memory looks like this. Let's come on here. If you have an array like that, the memory looks like this: 1, 1, 2, 2, 3, 3. It takes the columns and stacks them together. So basically, writing it like this would make more sense. So this would be the memory. And I can show you that in Matlab by using the column operator here. So this is the one-dimensional data that is inside or behind the scenes. And this is the matrix data. Of course, it's not possible to hold matrices in a sequential memory. What we do is we just stack data. So let's count the elements. There are 6 elements. So in C, if I define something like this, I would do it like this. This would be the C version. Let's correct it. So int let's say A, 6 elements, and it looks like this. This would be basically the C version of this definition. And if I want to access a certain row and column, I would just do the math here, calculate the position of the element, and return that. But Matlab does not choose to do this like row meter, I guess it is called. It does it column meter, which means that it has 1, 1, 2, 2, and 3, 3 in the memory, and it does the math for column meter. So if you type in 1, 4, it is the first row, so it calculates the first row, which one is the first row, and which one is, for example, the second column. So there's a slight difference there. And by using a semicolon, you can access all the data in 1D. But this semicolon is also important. You can do stuff like this. So let's say, let's get the first 3 elements of A. Now, what I've done here is I have given it a starting point, an ending point, and the semicolon, the column. So it starts at 1, counts up to 3 with increment 1. So it is possible to just examine this code itself, and you can see actually this generates an array. So 1 up to 10 just gives you the counting numbers from 1 to 10. So this is a nice way of creating arrays that have a starting point, a ending point. So I can also do 4 column, let's say 9. So it will start at 4 and stop at 9. There's also the possibility of defining the increment here. For example, I can say that start with 4, stop at 9, but the increment will be 0.1. And it creates that vector or array that I want to use here, which will be rather important in the upcoming lecture, I guess. So let's go back to our notes. Let me see. Yeah, we have something called cell array, but I'm not going to talk about that anymore at the moment because it will just confuse you. The only difference here is the following. If you are using square brackets and if you're defining stuff like this, the only limitation here is that the elements should have the same data type. But do not confuse this with this here, because of course here it still applies. Now it still did combine the elements here, but this time it decided that the character here is more dominant, so therefore this is a character array maybe, and it combined it like this. It's still treating 2 and 3 as characters, as you can see. So it did the type conversion if it's possible, but if you try to do something like this, you see now it converted into a string because this is even more dominant. So this is a string on its own, this is a string on its own, this should be a string, and this is an array of strings. So it is not possible to stick with the double quote AST and the numerical values 2 and 3 because it does convert it into stuff. Let's say false. You can see now this is treated as the string false. So it messes up the data type. It just converts everything into the same data type. Which one is the most dominant one? That will become basically the result here. And you can see, even though I'm just typing in single quotes into it, it is just converting it into double quotes because it has higher privilege than the single quote. So if I get rid of the double quote, let's see what happens. Now it throws an error because AST has not the same size as false, etc. But if you don't have false, it combines it into a string. So if you want to combine stuff together, most likely you don't mean the square brackets because it will mess up. You cannot access the first element of this and then add the stuff to it. You don't expect the results to be equal to for example, 4 because you have a character here, etc., etc. It's not safe to use square brackets in order to combine different types of data. Therefore, we have cell or struct, but I'm not going to touch base on them because it will just confuse you at this point. It is important to know what data types are, why we don't really use data type keywords here, int or float or double. We don't really use them as keywords here. We might use them as functions, and I have shown you that. You might use uint8, int8, int16. Those data types do still exist, so you can define them. The amount of bits are basically represented here: 8, 16, 32. Is there 24? There's no 24. There's 32. I wonder if we have 64. We have that a 64-bit integer, which can hold even longer now numbers. I guess it was long int in C, so long int. This is the equivalent there. You can have characters, you can have logical. Those are all functions, and you can just type in help. They are used to typecast, basically. There's a conversion, type conversion here. You have to provide it some stuff, and it will return you the logical version. As far as I remember, there's also a string here. So you can just cast in the string, the number into a string. Char should also work, I guess. But here you are in danger because this character, this didn't give you 1, 2, 3, because this char function here looks up the ASCII table here. Let me just so here it didn't actually convert that number literally into a string. Let me just find it to you. There's something called an ASCII table here. Maybe this one here. This good one. So this is an ASCII table here. There are 128, 126 even entries. I'm sorry. Now here, what they have done back in the old days is the following. Remember that you have a keyboard and there are characters on them. This char data type is more related to the keyboard than the characters themselves. And the American English keyboard, that's actually the standard for that. And each character has a decimal number assigned to it. There's also the octo and the hexa decimal representations. And then there's this character. You can look up the values here, and you can see what the decimal values are. And you can see that by converting it into int, in 32, I guess, you can see that so you can see that lowercase a, which appears here, has a decimal number 97. And if you use 97 to create a character, you can see that it gives you lowercase a. So these are basically all the English, American English keyboard characters that you can spawn using the ASCII table or the char data type. It takes up 8 bytes, I mean 1 byte for each character, but you can see from 127 to 255, there's stuff missing. So it should be double the amount of characters than here. But at that point, you get the extended ASCII table, and it depends on your language, display language, etc. So that's another topic. It doesn't really concern us, but we can use this table here in order to interpret what a character is or why we have the strange behavior. So let's come back here. So therefore, we have to know the data types. We have to know how to create vectors or arrays. In this case, you can also use unknowns in order to create stuff like this. We have some functions that might help us out. And from here on, we will have the conditions here, then the loops, and then functions, and that will conclude our introduction. So we have spent enough time for today, I guess. So I will stop here. Next week, we will go on from here. Now, I hope that you have seen how the lecture will progress. Of course, sometimes it might become a little bit boring because of the topics, but this is the most boring week, and next week maybe a little bit. But I try to exemplify and look for extreme cases in these, so we have a better debugging experience in this case. So I didn't actually show you that I can run Matlab here. So you can see that I can also run Matlab here. It's not really that big of a deal. And most of the time, I don't even use the Visual Studio Code, by the way. Let me just close this one here. So sometimes I just use CMD. Let me just quickly go here. I have basically also an external command line, so I can just maximize the window. Here again, I have Matlab, so help zeros just works the same, and it is basically based on the extension here, this Matlab interactive terminal extension. If you're interested in Visual Studio Code, and if you want to use Matlab for some reason here, you can just go ahead and take this route here. It will be a little bit of a painful thing to set this up, but once you have done it, you have just this nice code editor. There are some other stuff like Matlab styling for Visual Studio Code, etc., but it's not really that important. There's a question. When will be the first project announced? Well, I guess after 2 or 3 weeks, we will be talking about the first project, I guess. But these 1 to let's say 3 weeks, we will not announce the first project, but it will be it will take us a little time to prepare them and then announce them. So we have still time. Yeah, that's basically it for this week.